Hello everybody and welcome back. I hope you're all doing well. We're going to be looking at question number 3 on our 2011 open paper in this video. The faces of a cube contain the numbers 1, 2, 3, 4, 5, 6, such that the sum of the numbers on each pair of opposite faces is 7. So it's like a die, but instead of having the pips, they've just written the numbers. Okay, that's fine. But that's how it works. So opposite this 3, there's going to be a 4. Opposite this 2, so on the bottom, there's going to be a 5. And behind the cube, on the other side of the 1, will be a 6. Alright. For each of the cube's 8 corners, we multiply the 3 numbers on the faces incident to that corner, touching that corner, and write down the value. So in the diagram, we've got 1, 2, and 3, and they are all touching this corner. So that corner gets the number 1 times 2 times 3, or 6. What is the sum of the 8 values assigned to the cube's corners? Alright, now I like the regularity of this cube that opposite sides add up to 7. So I feel like there might be some sort of sneaky, tricky way to do the question, but that's just sort of a gut reaction, and I can't immediately think of what I could do. I mean, I suppose maybe the edge containing 2 and 3 is going to be 2 times 3 times 1 plus 2 times 3 times 6. When you add those together, that's just 2 times 3 times 7. So I guess we could try and be fancy like that and count up things based on edges, but then maybe there'd be double counting, and you can see how I'm wasting time just from a gut reaction. With a question like this, there's only 8 corners. Just figure out the sides. We already have. Multiply them out and add them up. I think that's probably the easiest way to go about doing the question. So, since I like writing things down, oops, went too far. Since I like writing things down, I will actually draw the picture again. We'll even write down, there's a 5 down here, there's a 1 here, a 2 up here, a 3 on this side here, a 6 back here, a 4 back here. I suppose I should make the 5 dotted as well, just to be really clear. Okay. And if we want to, we can sort of check these things off. 1 times 2 times 3 is 6. I'm using color just because I'm fancy like that. 2 times 3 times 6 at the back is going to be 36. Then we'll have, what, 2 times 6 times 4, so that's 8 times 6, that's 48. We'll use the yellow here for this corner. 2 times 1 times 4 is 8. Then we got 4 times 5 times 1 for the purple, that's 20. 1 times 3 times 5 is 15. 6 times 5 times 3 is going to be 90. And look at that, I didn't run out of colors. Everything that's hidden, 4 times 5 times 6, so that's going to be 30 times 4, 120. Alright, so if I add them up, let's take the things that end in 0. So 120 is 140, plus another 90 is 230. The 2 things that end in 6 add up to 42. The 2 things that end in 8 will add up to 56. And then 15, I guess, is just sort of left over. So 2 and 6, so that's 13. Carry the 1. 1 and 1 and 3 is 5, plus another 5 is 10, and 14. So 4, carry the 1. So 343, which happens to be 7 cubed, so I feel like there is a sneaky, fast way to do this. But, I mean, I couldn't think of one off the top of my head, and that's okay. 343 is just fine. It's just fine. That's all we need. So 343, and that's what we would write down. There aren't marks associated to style, so even though I'm sure there probably is a fancy way to do it, I don't need to come back and figure that out. I can go right on to question number 4. And if you'd like to, feel free to join me in the next video for that. I think I might. I feel like there's got to be a way to do the 343, so I'm going to try and play around and think of a way to do 343 7 cubed just as is. So if I imagine my dice and with A, B, and C, and 7 minus A back here, 7 minus B down there, and 7 minus C here, what could I have? Well, if I list out the possible values, you know, actually, if I, what could be a fast way? So, if I just look at these edges, each of these green edges is going to have two faces, and then one of the faces either A or 7 minus A. So the corners on the green edges are all going to look like some face times some face, and then A plus, and then we'll have to do some face times some face, 7 minus A. And so that'll be 7xy will be the sum of these edges, right? But then look at the red faces, right? That's what corners do you have on this face? Well, you've got two of these edges, and so you're going to have 7xy. So maybe if I do something like this to better explain. What I think we're doing really is just sort of building up based on adding up edges, the sum of the points on the end points of the edges. And now we're doing faces. So if I look at the red face, what are the corners that are on this red face here? Well, it's these two edges, and so we've got what? X up here, and Y is the red face that we're looking at, whatever that number may be. And opposite the X is a 7 minus X. And what are these sort of side lengths, or sort of, what are the edges we're adding up? Well, we're adding 7xy, and then opposite that is 7 minus xy. And so we'll have 7 times 7y is going to be the sum of the four corner values on the y face, and then opposite that is the 7y face. So the other four corners are 7, 7, 7 minus y, and if we add that up, we get 7, 7, 7, which is why we get the 3, 4, 3. Okay, so I think that's sort of a cute way to do it, but I'm taking a little longer time to try and explain it. I'm half explaining it, half just trying to investigate on my own. But that's why we get 7 cubed. So, more generally, if I had a cube and I labeled with, and this might be a question that I could submit to someone someday. But more generally, if I have a cube like this, and I've got faces, you know, A, B, C, and then on the back D, E, F, and I know that opposite faces add up to some fixed number like n. So B and E add up to n, and A and F were opposite each other. And C and D add up to n. If I do this same trick of assigning to each vertex the product of the faces around it, then I know the sum of all the vertices will be n cubed by the exact same reason. There wasn't something special about 7 other than opposite faces added up to 7. So that's kind of interesting, and if you've stuck around, you're sort of like me, you like investigating a problem even after the contest is done. And yeah, I hopefully it was worth it. I learned a little bit about this problem, more than I needed to know, but I think it's cool. Alright, so up next will be question number 4. We will finish off part A, and I will see you for that in the next video.